today's episode, we're sitting down with Avi Loeb. He's a guy researching 3I Atlas, which is the interstellar object passing our solar system. It's the third interstellar object passing our solar system that we know of. And this is incredibly interesting because it might contain alien technology. It might not. We don't know. It's an ongoing research effort. But even just the possibility that it might, really ignites a fire in me. And I think it's so interesting and so worth exploring, worth researching, worth getting the data on it, And he's really the guy who's doing that. And we sat down with him for, about an hour, a bit more of a conversation. And oh boy, it was really great. It was really, he's a really good person, first and foremost. Like you get the idea, when you sit down with someone, how they are. And he really seems genuine, honestly. He seems to genuinely care for science. He seems, he understands that this idea is maybe crazy, but at the same time, the people who are crazy enough to think they can change the world are the ones who do, right? As famously said by Steve Jobs. And at the end of the day, these are the people who end up being right. And that's why I really enjoyed this conversation. And I hope you will too. Cheers. Avi, it's so wonderful having you in the show. Thank you so much for taking the time. I've been a bit on a space odyssey actually with this podcast. Now, the episodes as we speak right now are not yet live. Probably by the time that people see this, they will be. But just last week, I was in Amsterdam interviewing Scott Kelly, the astronaut who was like for a year in space. 2 or 3 weeks before that, Robin Hanson, the guy who's famous for the Great Filter. Yeah. And I don't know, man, but for me, this space topic, it gets me going lately. It's so strange.
The way I think about it is when you read the news every day about terrestrial matters, geopolitics and so forth, you get disappointed most of the time because people engage in conflicts, they don't aspire to a better future. And the way I think of it, it's just like a party where all the participants are misbehaving. And the only hope I have when attending such a party is to look through the window for a new guest. And that's similar to your sentiment of hoping that something exciting will come out of space. Because, what we are doing on the surface of this rock that was left over from the formation of the sun is not very inspiring most of the time.
Yeah, I couldn't agree more. And really, it puts everything in perspective, completely.
Oh, yeah. No, I mean, most people ignore these facts. But first of all, we, as of now, I mean, maybe with AI-assisted medicine, situation will change. But as of now, we pretty much at best can hope to live for a century, each of us, and so... And I see people who died before that. They were big heroes, at least in their mind. They had a very high self-esteem and they tried to impress other people. Once they die, very little is left from that, so hoping to be recognized by other people and trying to get confirmation from other people is not really a target worth pursuing during your life. I think it's a waste of time. You need to focus on something that might give a meaning to your existence. And that has, that is well beyond getting a confirmation from other people. And the question is, what will really give a meaning to our life? And I was asked this question while climbing a mountain, actually, in Germany, near Schloss Elmau, which is the place where the G7 summits were held twice. And it was a gathering of influential CEOs and politicians. And I was asked this question, what will give a meaning to our existence? And I replied that it's finding that, we have siblings in the universe, in the Milky Way galaxy out there, because it's just like you live at home and you don't know whether you have brothers or sisters, and you might feel alone and you say, where is everybody? The way Enrico Fermi asked, where is everybody? But then if you find the siblings belonging to our family of intelligent civilizations out there, it would give a meaning to our existence, because first of all, the universe would not appear to be cold and lonely, like the way it is now. And, if you ask, I am doing research in cosmology, and I am always in the company of cosmologists that study the universe, and they and me as a cosmologist, we think all the time about the universe as being made of physical objects that are lifeless. But it's sort of like imagining a stage in a play which is made of objects, but there is no actor there. So that would lead to people like Elon Musk to say, we are probably alone. I think this is a very arrogant statement. I'm willing to bet, and I did bet with Elon Musk publicly, that there was a more accomplished space entrepreneur than he is over the past 13.8 billion years since the Big Bang. Because, there are billions of Earth-Sun analogs out there with similar conditions. And just imagining we are probably alone is very presumptuous. Okay, so if we find a sibling, in particular, a more accomplished member of our family, some other technological civilization that was able to accomplish much more, in the sense that they produced maybe relics that we can find around us, as an example. So these relics reached us. We didn't reach anyone else. So then it would, first of all, give us a sense of awe, because they might be more advanced than us technologically, and we will discover new technologies and new science out of that. But moreover, it will imply that we desperately need a sense of modesty, a cosmic modesty, and that dose of modesty will be delivered as soon as we realize what they accomplished. But more than that, are we alone is the most romantic question in science. So finding a partner out there, with whom we can potentially engage and interact, it will make our life much more meaningful, because we would realize how limited our view was, and our conception of where we are in the universe, and it will not be a lonely place anymore. And it will inspire us to explore space, perhaps visit those other civilizations, try to imitate them, because as we all know, Oscar Wilde said, the imitation is the sincerest form of flattery. So once you admire someone else, you imitate that someone. And it will also affect the way we, the way we think about the food chain, the cosmic food chain. We are not at the top of it, so there is someone better than us. And it's sort of like recognizing in traditional religions that God exists, that changes the way people behave. People who believe in God behave differently than those who don't. But here it's not a matter of belief. It's just finding, in reality, that partner, that sibling of ours. And it will definitely affect religions and affect the way what we aspire to do in the future, and give us a new meaning, a new purpose. And it will not be, coming from this rock that we call the Earth. The best that Elon Musk can aspire, his vision is, let's go to another rock called Mars. That's great. That's amazing. It's not amazing at all. Going from one rock to an even worse rock, where in that other rock there is no atmosphere. There is constant bombardment by cosmic rays. It's a desert with no liquid water on the surface. Like, who would like to go to such a rock that has no habitable conditions? Like, why would we do that? That's not visionary. What is visionary is to build a space platform that would carry us towards the stars, that would go interstellar. That's what we will be inspired to do if we find that others did it already. And I call that the Noah spaceship. It's just like Noah, who worried about the great flood in the biblical story, wanted to save animals, put them on an ark, and we can do the same thing regarding Earth, just to protect the future of humanity from catastrophe. But, if we just decided, instead of putting $2.4 trillion in military budgets every year in order to kill other people or to protect ourselves from others killing us, if we allocated $1 trillion every year to space exploration, I bet you that by the end of this century, we would have a space platform that can accommodate people for long journeys. And we just don't do that, because we are preoccupied with terrestrial affairs, like very narrow-minded views, and the best we can hope for is going to another rock. Like, what the hell? This is not inspirational. And so, I think it would give us a new meaning to our existence if we find evidence that we are not alone.
And it's just a much more exciting world to live in. It kind of makes your life in a way much more infinite, than finite. Because of course, if you stay here, yeah, you got 100 years. If you're lucky, maybe 120 with AI, with medicine, great. But there really should be more, And
Oh yes, I mean, you know what? The reason I want to live forever is simple, because there is so much we don't know. I would like to know that. Like, scientists often brag that we know so much now, much more than 100 years ago. But, we also know how much we don't know, which is bigger. Like, we know about the universe, how it started, the initial conditions that triggered what we see now. But it's amazing to admit how ignorant we are, because, we give Nobel Prizes for people who quantify how ignorant we are. That's crazy. Like, we give a Nobel Prize to someone who says a certain fraction of the energy in the universe, most of the energy, 70% of the energy in the universe, is in the form of something we don't know. So let's call it dark energy. You get a Nobel Prize just for finding that. Well, what have you found? You found a substance that you have no idea about its nature, and you just realize that there is something we don't know, and you get a Nobel Prize for that. Like, this is what we celebrate, and for scientists to be arrogant and very sort of confident of how much we know, it's really inappropriate. That's just the energy. Then there is the whole point about dark matter. We know that most of the matter in the universe is not what we see here on Earth. It's invisible to us. We call it dark matter. So dark energy, dark matter, we don't know what they are. We just give them labels, and we celebrate the fact that we realize that they exist. Okay. And then we don't know what happened before the Big Bang. Like, there was a point in time before when our theories just break down. Einstein's theory of gravity cannot forecast what happened before the Big Bang, because it breaks down at that point in time when the density of matter and radiation were infinite. We don't know what happens inside a black hole. There are so many things we don't know. We don't know how to unify quantum mechanics and gravity. And so, a sense of modesty is appropriate, both because we live for a short time and because we realize how much we don't know. All these things that I mentioned that, were recognized by the Nobel Committee are pretty much admission in our ignorance. And it's just inappropriate for us to be so arrogant and say we are representing the top intelligence that may exist. And I say there is a lot of room for improvement, and one way for us to figure it out is, find someone who is more intelligent. So one reason for me to search for extraterrestrial intelligence is because I don't often find it in academia here on Earth.
Mm-hmm. And what is, as of today, 21st of October, what are kind of the best insights we have scientifically that there are aliens? Because I could really make the argument both ways. I could make it's going to be fantastic if we find them, but I can also make the argument at the same time it's going to be horrible if we find it, depending how you look at it.
Oh, that's a great insight, because when you go on a blind date, and here we're talking about blind date of interstellar proportions,
mm-hmm.
Most of the time you imagine the other side to be very friendly. You would imagine that would be the result of the blind date. But every now and then you have to worry about sitting next to a serial killer. That is a possibility, especially when that other side comes from another star. All bets are off. And that is something we definitely need to contemplate when we will encounter alien technology. Because we all know about the story about the Trojan horse that looked very innocent, but ended up destroying the city of Troy. And yes, we don't know what the other side is. But one thing we know for sure, and that is, if you sit at your home, or if you are Enrico Fermi having lunch in Los Alamos in 1950, and you just ask, where is everybody? You are not doing much. You're not doing your job. If you really care about finding a partner, if I was next to Enrico Fermi, I would say, Enrico, this is a question that every lonely person asks. And what you tell a lonely person is, you should be proactive. You need to go to dating sites. You need to look through the window of your home to find partners. You can't just assume they will come next to you and have lunch with you. And so he did not build a telescope. Now, when people say, extraordinary claims require extraordinary evidence, I reply, extraordinary evidence requires extraordinary funding. And you need to put the time, the effort, the resources. And only if then you don't find it, you can say, okay, well, at least I tried, but maybe it doesn't exist. But that's not being done. It was done, for example, in the context of dark matter for 50 years. Weakly interacting massive particles that are the lightest supersymmetric particles, a new symmetry of nature, supersymmetry that was, when I started astrophysics 40 years ago, was celebrated. Everyone believed it exists. Then the Large Hadron Collider at CERN looked for it and didn't find it in the natural parameter space. So here the entire mainstream was going in a direction that ended up not being correct. And, it cost $10 billion to build this collider. Okay. So nobody said it's an extraordinary claim, therefore we shouldn't contemplate it. People said, oh, that's a great claim. Let's put $10 billion and search for it. Okay. So now in the context of aliens, people say, well, it's extraordinary. Let's not put any penny into it because it's too speculative. Now I ask, why are you saying that? We know that we exist and, we started from a soup of chemicals. Everyone would argue that, we started from a soup of chemicals on a planet, and we see billions of other planets with similar, circumstances. So it's not extraordinary to imagine that. It's actually more likely to be valid than arguing for supersymmetry. The way the mainstream for 40 years did spend $10 billion to look for that. And I said, let's put billions of dollars. We haven't done that. Billions of dollars towards the search for aliens before you say anything against that. Now, with respect to, what the mainstream really wants to do is the highest priority in the 2020 Decadal Survey of Astronomy and Astrophysics in the United States, the highest priority was defined to be searching for the molecular fingerprints of microbes in the atmospheres of exoplanets. Meaning, it's just like living on a street. You have your home, there are microbes at your home because things get dirty all the time. You look down the street and you say, oh yeah, there are probably microbes in the other houses on the street. Now, for you to detect these microbes from a distance, from your home, looking out at the street, requires, a huge facility of observations. And it costs a lot of money. The signatures may not be clear-cut because there might be other reasons for why you are seeing things at a large distance. And so you would invest a huge amount of effort and money to just do that, detect those microbes. But if there is one resident in that street, one resident, not just microbes, that one resident may show up at your front door. That resident might throw a tennis ball that would arrive at your backyard, or that resident may have some construction project in their backyard that you can see from a distance. So even though that resident might be rare relative to microbes, it might be easier to detect that resident. So my point is, let's hedge our bets and put billions of dollars towards the search for intelligent signatures, technological signatures, as much as we put towards the search for microbes. But no, that is considered heresy. Heresy to the point of people not just attacking the argument. Those astrobiologists that want to find microbes, they're obsessed with microbes. They just want to find microbes. They don't want to talk about intelligence because it's too speculative, even though we exist and we are asking these questions. And, my point is, this is not heresy. This is common sense. And by the way, the public fully understands that. And guess what? The public funds science. So how is it that scientists who are funded by the public, which is very curious about this specific question, is there intelligence out there? How is it possible that the scientists refuse to use the public's money to address this question? Can you explain that to me? I just cannot understand that.
I mean, if it's up to me, sign me up. We go tomorrow, 100%. And I guess what I'm really curious about, because you're so deeply into this kind of, whatever, industry or whatever you want to call it. And where are we currently standing? Are we currently standing in a way where we basically need much more money to actually find stuff? Have we already found stuff that we can kind of extrapolate into other findings? Like, where do we stand today?
Yeah. So here is the way that scientific revolutions happen. And, that's substantiated by the history of science. There are many examples. Initially, someone or several people notice anomalies, meaning we have a paradigm. Everyone thinks about the subject one way, but then you collect evidence about a new object, some new phenomena, and it doesn't line up with what everyone believes. So then what happens? The experts would shove the anomalies under the carpet of traditional thinking. And I can give you examples in the context that I'm speaking about, but there are many examples in other contexts. The experts not only shove the anomalies under the carpet, but they also suppress anyone who tries to highlight the anomalies. And how do they suppress? Either by ridiculing that person, and there are many examples, going all the way back to Galileo, but there were also continental drift is an excellent example. For 40 years, the person was completely ridiculed by the mainstream. And then people realized 40 years later, after he died, a decade after he died, that he was correct, that there was a drift of the continents. They came from a common origin. There are many examples like that. So there is this tendency of the experts not only to hide the anomalies, but also to suppress and chase and bring down to the ground, tear apart whoever is trying to advocate for those anomalies. Why? Because they feel it's a threat to their expertise. If they were arguing that they understand nature, nobody is allowed to dispute the fact, because all their prestige, status is based on past knowledge, and it threatens their ego to recognize that their knowledge is incomplete. So they are attacking aggressively and sending, zealots, other people, to basically chase those people and bring them down. And today it would be done through social media. It would be done through talking to reporters. It would be done through editors of journals that do not even send papers for review because they think that the paradigm is correct. That happens as well.
Mm-hmm.
And it will obviously happen when somehow the paper is sent by another way to kill it is by sending the paper who claims there is an anomaly to an expert in the field that doesn't want the anomaly to be known. What happens then? The expert says, well, what did you think about this, that? Either you moderate the language to say, this is completely uncertain and we don't really know what is going on, where the paper loses its thread, or the paper is declined from publication. And then those experts that basically suppressed the counter opinions, they go out in public and say, oh, this argument was never published in a peer-reviewed journal. Why wasn't it? Because you personally suppressed it. And they don't say that. They don't say that they were personally responsible for talking to the editor so you end up with a situation where either, if the person is a junior faculty, then obviously they have a big problem because they might not get tenure. So the whole idea of tenure was to allow us to visit ideas that are not being embraced as of yet, so that we make discoveries, right? That's the whole idea of tenure, that you have job security. But human nature goes against that narrative. And what you end up finding in academia right now is a group of senior people that have tenure in many countries that basically are using the status they have in order to create echo chambers that amplify their voice and allow them to get more funding and more prestige and more honors. And basically, in the context of that, they will never take any risk. They will not try to look at something that could end up being wrong. Why? Because that would damage their prestige. And, but that is the wrong motivation, because you are supposed to worry about what does nature tell me? If there are these anomalies, maybe we don't fully understand nature. And, I can give you just one quick example in the context of what I was talking about before. There was the first interstellar object from outside the solar system. It was called the Oumuamua because it was discovered by a telescope in Hawaii. And the name means a scout from far away. And immediately as it was discovered on October 19, 2017, immediately all the comet experts declared, this is a comet. Let's Comet Oumuamua. That's it. In the initial paper's discovery, they called it a comet. But the problem is, even the Spitzer Space Telescope looked very deep around the object, didn't find any traces of gas or dust. Nothing. And obviously, a comet is often clearly showing a tail of gas and dust that is stretching away from the sun because it's being pushed by the solar radiation and the solar wind. So not only there was no evidence for such a thing, even when a telescope was very focused on the task of, with a long exposure, looking for any traces of molecules around this object, nothing was found. So then the experts said, oh, no, sorry. It's not a comet. Let's take out that label. It's actually an asteroid. An asteroid is a rock that doesn't have ice on the surface, so nothing evaporates. That's it. So it just moves along a trajectory that is sculpted by gravity alone. Then data indicated that the object actually exhibits non-gravitational acceleration, meaning it's being pushed by some force. Now, such a force could be associated with a comet, but you need the comet to lose 10% of its mass in order to exhibit that much non-gravitational acceleration in that case. 10% of its mass is a lot. You should have seen a cometary tail. So what did the experts say after 7 years? After 7 years, during the 7 years, some experts said, oh, maybe it's a hydrogen iceberg. Maybe it's a nitrogen iceberg. Maybe it's a dust bunny. That was the mainstream. Look, we can explain it as a natural object. It's just a rock that we've never seen before. But it's natural. Let's not put on the table the possibility that it's artificial. So that was the discussion. And then after 7 years, when they realized that, a hydrogen iceberg has problems, it won't survive the interstellar journey. Nitrogen iceberg is just, you don't have enough solid nitrogen to provide the population. The dust bunny would get destroyed when it comes close to the sun because it needs to be very lightweight. And then there was a paper just less than a year ago saying, now we know what it is. It's a dark comet, meaning it's a comet, but the tail is invisible. Now, this is just like going to the zoo and looking at an elephant. And because you're an expert on zebras, you say the elephant is a zebra without stripes. But that's actually a cheat. Why is it an intellectual cheat? Because you're giving it a name as if you understand what it is. You call it a dark comet, but the signature, the key signature of a comet is not being seen. So why are you cheating and saying it's a comet? Why is it a dark comet? I mean, that's what you would call a spacecraft as well. A spacecraft moving without any cometary tail, you would call it a comet. Anyway, so this is just an example for how an anomaly can be shoved under the carpet of traditional thinking. We call it a comet, but it's a new type of comet. It's a comet of a type that we've never seen before. And then you relax and you say, we don't need more data. We know what it is. It's a dark comet. And whether it's real or not is irrelevant as long as you suppress the conversation. You say, oh, the possibility that it's something else is debunked because it's a dark comet. And I see reporters still saying, oh, it's debunked. I said, what are you talking about? We don't know what this object was because dark comet? Okay, so explain to me the mechanism. What is it made of? And how would it survive in interstellar space? So, and the same is true about the new interstellar object, 3I Atlas. People would make statements. It's a comet. But then you say, oh, what about the 8 anomalies that it exhibits? There are 8 anomalies that I listed. Explain to me those anomalies before you say that you fully understand it. And they don't try to explain these anomalies. As long as they suppress the conversation, that's good because then we can relax and move on. And the problem with relaxing is that you don't collect a lot of data because you think you know what it is. But my objective is to continue the discussion such that we get as much data as possible. I love to have as much data as possible. Why? Because, in the days of Galileo, he looked through his telescope and argued, not all celestial objects revolve around the Earth. He saw the moons of Jupiter moving around Jupiter. So the church basically put him in house arrest, exactly the same response. And then in 1992, 350 years after he died, they admitted that he was right. That was the worst public relations affair that they could have had. 350 years later, they admit that he was right. Okay, but why did you give him so much trouble? This is ridiculous for you to admit in 1992, 2 decades after humans went to the moon, to admit now you realize that the Earth is not at the center of the universe. Come on. So that was not good for the church public relations. They could have done much better if they said, oh, we have much more money than Galileo. We can build a bigger telescope at his time, and we will prove him wrong. Now, if they would collect much more data than he did, they would have realized very quickly that he was right. So a flood of data doesn't allow the quote-unquote experts or clergy to maintain their views. The only way that they can maintain their views is if they suppress the collection of new data. Okay? So if the scientific community says everything in the sky is rocks, and we just assume that, and if we see something unusual, we call it an anomalous rock, a rock of a type that we've never seen before. That's what a cave person would say. Imagine a cave person looking at a cell phone. The cave person would look at the cell phone and say, well, it's a rock of a type that I've never seen before.
Yes, that's a good one, actually. Because what strikes me here the most, actually, that it all of a sudden moves away, because you would expect if it is a stone, it just follows gravity and it does its thing, right? And it doesn't add up. And, in my humble opinion, it actually reminds me of a quote of Steve Jobs, the people who are crazy enough to think they can change their world are the ones who do. And it sounds like this establishment is not crazy enough, which is not a compliment, right? And it sounds like...
There is an anecdote which lines up with what you just said. There was a PhD student named Jacob Bekenstein. He died recently. And he was a PhD student at Princeton in 1970 or so. And he realized that, Stephen Hawking proved that when you merge black holes, the area of the new black hole that results from mergers is always bigger than the sum of the two areas of the two original black holes. So Bekenstein was a young student, and his advisor was John Wheeler, a legendary physicist. So he came to his advisor and said, look, this reminds me of the second law of thermodynamics, where entropy can only increase. So maybe, black holes have entropy that is proportional to their area. So that's why when you combine them, you always get a bigger area, bigger entropy. Entropy always increases, second law of thermodynamics. And Wheeler responded, this is so crazy that it might be true. Yeah. Now, Wheeler was, a visionary. He always, was sufficiently generous to encourage people around him to be innovative. So then Bekenstein wrote this paper and gave a presentation about it. And Stephen Hawking heard about it. And he said, that's nonsense. Stephen Hawking said, that's ridiculous. Who is this guy? I mean, there is no entropy to black holes. That makes no sense. And I will prove that. So he started calculating quantum mechanically whether the vacuum near a black hole is any different. Because he said, if there is entropy, there must be some thermal effects. And, you might see some radiation or something. Anyway, he wanted to show that Bekenstein is completely wrong. He did the calculation and realized that Bekenstein was right, that there is actually radiation coming out of black holes. And this is called Hawking radiation. So he published it. So he went to disprove Bekenstein and realized that he was right. And this became, something that the entire community of theoretical physics is obsessed with over the past 5 decades. Okay, obsessed with. Like there are tons of papers on this. Now, all of this is just theory. We've never observed Hawking radiation, but it just goes to your point about something that looks crazy. If it turns out to be right, will change the world. I mean, in this case, the world of theoretical physics.
Because in my opinion, even if there's, I don't know, a 0.001% chance of this actually being aliens, I want to freaking know.
Yeah,
I want to know.
So here is another example, and now I'm going into another domain, which is defense related. Just think about what happened on October 7th, 2023 in Israel. The intelligence agencies in Israel, the Israeli intelligence agencies, which, get all the data they can from satellites, from people on the ground, they got the data about the potential of something happening, and they ignored it. They completely dismissed it. They thought the probability for that to happen is pretty much zero. Our model of the world says this will never happen. They ignored the data, and that was a big fiasco that led to the death of many people on both sides. Okay? Now, obviously the duty of intelligence is to consider black swan events that are very unlikely. Even in your mind, you can argue why it's unlikely politically speaking, but given the consequences, you have to consider them. And somehow, those intelligence agencies did not consider a black swan event. That's their job. They're paid to do that. They're getting lots of data. So that was disastrous to the Middle East. And just think about, some young people there saying, oh, wait a minute, look at this data. There could be a black swan event. Why don't we examine it more carefully just to make sure that it's not going to happen? How many lives would have been saved? And so the intelligence agencies, I'm sure right now, they are discussing any black swan event, like even a small probability, just because of the implications. But in science, what's the worst that we can, suppose we imagine that an interstellar object is not natural. Okay, suppose we just say the probability for that is small, 1%, whatever you want it to be. And I can argue that it's actually much bigger for 3i Atlas. Even if you say it's very small, the worst that can happen is you say, okay, but I want to check very carefully. Let's use all the telescopes, all the space assets to observe this object and collect as much data as possible. Would that be so terrible? That would be great, because then even if it's a natural object, you will know much more about it. These are rare events. So what's the big deal? Why ridicule this discussion? Why ignore it? Why say that it goes against science? It's really strange. I will give you a couple of examples. One, there were conspiracy theorists, and they said that I'm discussing this object as a distraction from the Epstein files. Now, if I had the opportunity of creating an object that is 10 kilometers in size at a distance of 4.5 times the Earth-Sun separation, I would be more powerful than the Pope. That's like telescopes looking at it from the Webb telescope, from space, from the ground. You can see an object coming. That's a crazy notion that I am orchestrating this thing. And then, the point is, we have various assets. I argue that we use a spacecraft near Jupiter to observe it, and then immediately some scientists said, well, it doesn't have enough fuel, we shouldn't really use it. Then, it's really strange. Why wouldn't people cheer to the opportunities to observe this thing as much as possible? Then some say, oh, I'm really waiting for it to go away so that we will not have to discuss it anymore. This is really terrible. Why? Because if we don't get enough data, we end up in the situation with Oumuamua where we don't know the answer. Of course, you can brush it under the carpet of traditional thinking, but the fact that we are ignorant doesn't change nature. If we, for example, the Earth was moving around the sun 4.54 billion times. Just think about it. 4.54 billion times, going around, billions of times. And before the Vatican even existed, then the Vatican comes along and says, no. The sun is moving around the Earth. That's what the Vatican says. Who cares? The Earth was moving already 4.54 billion times. The Earth continued to move additional, hundreds of times after the Vatican said that. And whether the Earth moves around the sun or vice versa is a matter of fact. It has nothing to do with what the folklore, what is popular among humans. What if the church convinces everyone that the sun moves around the Earth? It doesn't change anything. And the same is true about whether we have a neighbor. We can sit at home and argue forever and ridicule every member of our family who says that we have a neighbor. People can attack me, destroy me, write on me on social. Who cares? If we have a neighbor, what you do to me is irrelevant. And so what we want is really to find out, right? And you shouldn't attack the messenger. You should examine the message and check whether we have evidence or not. So for a variety of reasons, we have not collected enough data to address the question, are we alone? But we have an opportunity. And I just wrote this morning an essay. I usually write on medium.com. You can subscribe for free. I don't charge anything. I wrote an essay why interstellar objects are a new frontier that would revolutionize astrophysics. You know, even if you imagine just rocks arriving into our backyard from another star, you know, these rocks took millions to billions of years to make the journey. And that's our opportunity to examine the materials they're made of, because we can check whether the building blocks of life as we know it exist on those rocks. That's, you know, that's a completely different approach than looking for the chemical fingerprints of microbes in exoplanets. Here you have an object coming next to you from another star. Why don't we land on it, collect 100 grams, bring them back to Earth? This is called the sample return that was demonstrated by the OSIRIS-REx mission to the asteroid Bennu. Asteroid Bennu was from the solar system. I'm saying let's do the same with interstellar objects. So it would revolutionize astrobiology, even if everything is rocks. Okay, so that's an opportunity. And then imagine us getting close to an object and realizing that it's not a rock. It's actually a technological object. Why? Because it maneuvers, it emits artificial light, it has some excess heat coming from it that does not reflect the reflection of sunlight. So, you know, if that happens, that obviously will have a huge impact on the future of humanity. So we should take advantage of this new frontier that would, you know, traditionally astronomy was done remotely by observing distant objects that are across the cosmos at distances of, you know, billions of light years and on over timescales of billions of years. But, you know, these are much bigger than what we can explore directly by sending a spacecraft. And so there are objects that made the trip already, arrive at our backyard. Let's examine them. It's a completely new frontier. And we should allocate a significant budget to this exploration. And my hope is we will find some technological relics out there. Because we ourselves, as a technological civilization, over the past 50 years, we sent 5 probes to interstellar space. They're making their way out, and just imagine a Voyager coming to another planetary system. It would look like an interstellar object, and, you know, only the curious astronomers over there would realize that it's not a rock.
Well, I would even personally chip in for this effort because I'm so excited about it. You know, even if there's, I don't know, just a 5% chance in my lifetime that we find anything like that, it pumps me up. And it kind of brings it to the question, what is your kind of percentage likelihood that you think these objects are, well, I guess alien in a way, right?
Oh, yeah. So, by the way, I didn't mention that on January 2nd this year, there was an object that was cataloged by the Minor Planet Center as a near-Earth asteroid. And then a day later, they realized, oh, wait a minute, this object is moving along the path of the Tesla Roadster car that was launched by SpaceX. So it was not a rock, it was not an asteroid, it was a car. And the only reason we knew that is because it was launched by SpaceX. But just imagine a car like that being recognized by astronomers, they would say it's a rock of a type we've never seen before. Anyway, coming back to your question, at the moment, I give 3i Atlas a rank of about 4 in a scale that I defined a few months ago. It's called the Loeb scale. There are 2 papers quantifying it. Basically, a 0 is an object that is definitely natural, like an asteroid or a comet, and 10 is an object that is definitely technological that could be a threat to humanity on Earth. And I give it a 4 because of 8 anomalies. The first one is the size of the object. I wrote a paper just a few weeks ago that derives a lower limit on the mass of the object because the object appears to move along a path that is carved just by gravity. So very different from Oumuamua. There is no evidence for non-gravitational acceleration, despite the fact that we see evaporation from it. So we see that on the side facing the sun, it's losing about 150 kilograms every second from the illumination by the sun. So there should be a push or a reflex motion of the object, a recoil of the object as a result of this mass loss towards the direction of the sun. And that was observed by the Hubble Space Telescope, this plume of material that is coming from the side that is facing the sun. So we don't see evidence that it gives a recoil to the object, and that means the object is very massive. It needs to be at least 33 billion tons. That's what I calculated. And that means that if it's made of a solid density, then the diameter is bigger than 5 kilometers, comparable to Manhattan Island, or, you know, it could be as big as the asteroid that killed the dinosaurs. The object is really big. So that is a problem because it means the object is at least 1,000 times more massive than the previous interstellar comet that was called Borisov. And it's 1,000,000 times more massive than Oumuamua, the one that I mentioned. And so this is the third object. Why haven't we seen 1,000,000 Oumuamuas before seeing this one? Like the fact that it's so massive relative to the previous ones is really puzzling. And moreover, there is not enough material per unit volume in interstellar space to deliver a rock of that size once per decade to our vicinity. It's just impossible by orders of magnitude. So this is anomaly number one. And then on top of that, the object appears to be coming exactly along the plane of the planets around the sun. It's called the ecliptic plane, within 5 degrees of that plane. The chance of that happening at random is 1 in 500. So there is a question, why are we seeing this object coming in the plane? Is it by intelligent design that the purpose was for this object to probe planets in the solar system or release some mini probes that would interact with the planets? And then we see in the gas plume around it, we see much more nickel than iron. And that was never seen in comets. Nickel without iron, usually nickel comes with iron, comparable levels. In fact, the solar composition has more iron than nickel by mass. So the only other place where we see nickel without iron is when we produce nickel alloys industrially through what is called the carbonyl path. And so the astronomers that reported about the nickel without iron, they said, well, maybe nature does it as well. And I say, well, maybe nature does it, or maybe the surface of this object is some artificially produced alloy. Okay? And water makes only 4% of the mass loss from or at least the plume of gas around the object, only 4%. When the object was discovered, all the comet experts said, oh yeah, of course, it's probably just water. It's not. And then in addition, there is a negative, extremely negative polarization of the light coming from the object. There was also a plume, a glow stretching 10 times longer than it was wide towards the sun. Usually with cometary tails, they are pushed away from the sun. In this case, during July and August, the images we have are showing an elongation of the image in the direction of the sun rather than away from the sun. And you would expect dust or gas to be pushed away from the sun. Why is it that you see the elongation towards the sun? This needs to be explained. It's called an antitail. Sometimes you see an antitail which is completely fictitious as a result of perspective. You're looking at it from some direction relative to the sun, and it looks as if it's heading towards the sun, but it's always pushed away from the sun. There is no explanation for why 3i Atlas should have an elongated glow towards the sun, except I tried to explain it in a paper that I wrote with Enrico. And so, these are anomalies that, and finally I realized that the object arrived within 9 degrees from the direction of the WOW signal that was discovered in 1977. It was a radio signal from an extraterrestrial origin that was never explained, and it was figured out that it's coming from a source that is moving towards the sun, and the chance of the direction of the WOW signal being in the same within 9 degrees from the direction of arrival of 3i Atlas is 0.6%. So that's another anomaly.
And if we get really creative, what would be your best guess? What is it? Like, let's say we assume, okay, it is alien, it is something that we don't understand. Like, what kind of attributes can you kind of extrapolate or understand from that? And what would be the closest fit that we know? Or maybe we don't know. I don't know.
No, I prefer not to imagine anything. I just want the data to speak for itself. Of course, if you want to imagine, you just read the science fiction novels. Like, for example, Rendezvous with Rama by Arthur C. Clarke. He envisioned an object roughly this size of tens of kilometers as a cylindrical spacecraft that visits the solar system. And astronomers recognize it. and there are lots of science fiction scripts based on similar ideas. There was also Don't Look Up, this recent film. And by the way, the experience of the scientists there is not very different than mine. People just didn't want to listen, including politicians. Nobody wanted to hear about it. So my sense is, as long as we survive the first encounter, then it will change everything, because we would realize that there is some alien technology out there, and we would want to be alerted to any threat in the future. So as long as we survive the first encounter, we will probably allocate $1 trillion a year, a significant fraction of the military budget worldwide, to install, to deploy interceptors or space telescopes in the outer solar system that would alert us about incoming technological objects. Because if you see them early enough, you can design a path that will intercept them. If you realize that they arrive too close to us, you can't do much about it.
And what kind of evidence kind of would make you finally say, we found it or them or whatever?
Well, it's very simple. If we have a high resolution image from a flyby close to it that shows that it's not a rock, then we know. Or if there is a transmission of some electromagnetic signal, maybe a radio signal or something else, or if we see artificial lights, or we see just maneuvering. So 3i Atlas is coming closest to the sun on October 29th, and that's the optimal point for a maneuver. To take advantage of the gravitational assist from the sun, we do that very often. It's called an Oberth maneuver. When you pass near a massive object, you want to use the point where the velocity of the spacecraft is highest, because then if you fire your engine and get a thrust along the direction of motion, you get the most kinetic energy gain out of that. If you fire it against the motion, then you can slow down. And in principle, 3i Atlas could do that when it comes closest to the sun. We won't be able to see it because the Earth is on the exact, as of today, actually, it's on the opposite side of the sun. And that's, again, a question of whether that was designed for us not to be able to see any maneuver that it does at that point. Or it could just continue along its path. If it's a mothership, that would be the least energy consuming approach. It could release mini probes that maneuver accordingly, and they require less energy. And then we would see these visitors, small mini probes visiting the planets, including the Earth, in subsequent months. That's something we should watch out for. And I actually asked, I'm leading the Galileo project where we are monitoring objects in the Earth's atmosphere. And I asked my research team to keep their eyes on any unusual activity in the coming months.
Now, if you had to speculate, do you think the establishment is just ignorant to kind of ignore this or to even undermine it? Or is there, I don't know, something bigger going on? Because the way you're describing it, it sounds like they really don't want you to look, That's just what I'm hearing right now. And I wonder, what is your view on that?
Yeah, so of course, if you are dealing with a virtual reality or some narrative, you can, or in some argument in politics, you can ask the other person not to think about it because you don't want it to be discussed. But if we are dealing with something in reality, it really doesn't matter what I say, what they say. They have to recognize the fact that if there is something out there, it's not to our benefit to stay ignorant about it. If we stay ignorant, if there is traffic of alien technology near us and we are not aware of it, of course, we would continue to think that everything in the sky is rocks, and the comet experts will get awards, funding, and everything will be fine, but we would still be ignorant. Is that better? I don't think so. I think it's good for us to know what reality is. Even if it's a threat, even if it's something that we don't want to hear, we need to know about it. It's called inconvenient truth. Like you want to know the truth because then you can design strategy how to cope with it. But arguing that we don't want to look is terrible. That's anti-scientific. And to hear it from scientists is the worst. Like they're supposed to be, so that it's just like letting the cat take care of the milk. Like they're supposed to be the ones collecting data, no matter what the data shows. but they are very much opposed to contemplating a possibility, and therefore will not collect any data on it. But this is ridiculous. I think there needs to be accountability of scientists also to the public. You can't just say, we want to explore dark matter, we don't want to hear about alien technologies. That's irrelevant for us. We believe that it doesn't exist. Like, who are you to say that? You are funded by other people's money and you are ignoring what they're asking you to do? And moreover, just imagine that things like that do happen, and we ignore it because the scientists are not willing to consider that possibility. Like, how better is that compared to the Vatican responding to Galileo? Like, why are we thinking that, scientists today are doing better than the clergy back then? And
It reminds me actually, it reminds me of my personal approach to my own health. It's like I'm a bit kind of, into proactive healthcare, rather than reactive healthcare. And I'm like, I want to know if something's not good.
Yeah.
I want to know if my blood markers are inflamed. I want to know, I don't know, if once every 3 years I see something on an MRI. Well, 99.9% I'm going to be fine because I'm young, I'm healthy, it's all good, but I want to know. And I feel like it's almost the same thing, if there is even a slight chance that there might be something, we have to know.
Exactly.
All the other options are really worse.
Because if you find it early enough, then you can do something about it.
Exactly.
Otherwise, you are fatalistic. You say, okay, I don't have cancer, I don't have any illness. And then when you do have it, you will die. That's it. Because you didn't do anything to address it. And so, it's foolish. But the fact that, what I find problematic is that these are people who are supposed to follow the guiding principle of science, which is we should abide by evidence. And that means you need to seek the evidence. Now, if you say a priori that the evidence does not exist, therefore we shouldn't even seek it, then you are not considering black swan events that I was arguing for. Like, if you are just thinking about the sky in terms of what you already know, you would obviously not discover that you don't know something. And then the whole point of doing science is to collect evidence on new things that you did not anticipate, because that would, open up new knowledge. And why would anyone be hostile to saying, let's collect as much data as possible so that we can rule out that it's anything but natural? Like, why would anyone have a problem? Or if we didn't collect enough data, why would anyone say, oh, it must be a rock of a type that we've never seen before, we don't want to discuss anything else? Like, where is that coming from? We know that we launched technological objects to space. So we know that such objects exist. And we know that we made mistakes and classified technological objects as rocks, like the example I mentioned on. And there was another example by the same telescope that discovered Oumuamua. It discovered 3 years later an object pushed by sunlight turned out to be a rocket booster from a 1966 launch by NASA. So these things are found every now and then. We realize, we we thought it's a rock, but it's not, because the reason we find out is because we know what we launched. But if someone else launched something, you have to allow for that possibility. Why is that heresy?
And you can literally just use logic here, Think of, I don't know, humanity. Right now we have like 100 or 150 years where we've kind of been technologically savvy, let's say. And the amount of space junk that we have out there already, in this short amount is huge. It's huge. Exactly. And if now you think, what if, I don't know, a civilization was there 1,000, 10,000, 20,000, 50,000 years, which really, looking at the universe, is really a reality, that we might have.
Exactly.
It's really not unlikely if you just use simple logic here.
Yeah. And as I said, common sense is not common in academia. But here is another thing that academia is missing. I got an email, and I get a lot of interesting things now. Like for yesterday, I got 51 watercolors, which are paintings, plus 2 bronze sculptures of Galileo Galilei delivered to my office. From an artist called Greg Wyatt. On Saturday this week, just a few days from now, I'm going to a NASCAR car race that one of the racers there decided to put my image and the image of 3i Atlas on the hood of his car. So I'm going to be there. A day before that, I have an interview with Joe Rogan on a podcast. And then, just yesterday, while the carpenter was putting these watercolors on the walls of my office, I had a Zoom call with Eric Adams, the mayor of New York City, who wanted to ask me some questions. So I get a lot of very interesting encounters, but the most rewarding one was an email that I received from a former pilot in the U.S. Air Force, and he said, "Because of you, my daughter wants to become a scientist now. She keeps talking about aliens, and she wants to be a scientist." And I found that to be the biggest reward that I can get. It's not a prize. I don't care about, getting the Nobel Prize. It's really not interesting. But when I managed to convince kids to become scientists, how much better can it get? And why am I able to convince? I've never met this daughter, and she's inspired by the fact that, I behave like a kid. I just ask questions and I want to know the answers, and I don't have a prejudice, and I don't pretend to know more than I actually know, which is the way a kid behaves. I haven't changed much, and I see science as an opportunity to maintain your childhood curiosity. And so this daughter of the pilot recognizes that. She resonates with me. I don't speak with her, but she recognizes that science can be an opportunity to learn. Okay? And how often did any physicist convince kids to become scientists? Like, even if you discover the Higgs boson in the Large Hadron Collider, I bet you that this daughter would not feel connected to the Higgs boson, and that would not convince her necessarily to become a scientist. But the search for intelligence beyond the solar system, beyond Earth, is something that appeals to so many kids and is avoided by all scientists, or even the scientists that care about it. They always apologize speaking about it, and they say, no, we don't really know. We just have upper limits. We don't really want to. And then when they see someone like myself talking about it, they attack me. And this daughter doesn't care about their attacks. She's fascinated with the question. And so, this is an opportunity to bring science to the young generation so that there are more scientists, to make science not look like an occupation of the elite, to make it look like an attempt to satisfy our curiosity, to give us a meaning. And I feel that it's a missed opportunity. So it's not just the fact that there is this pushback, but the fact that there is a missed opportunity to use this specific subject that I'm talking about, that specific thing that those people are attacking me for. This specific thing is a key to bring science, to elevate it in society, to get more funding for it, to get more kids excited about it. It's exactly the opposite of what those people are claiming. They claim they want to protect science. And some of those protectors, quote unquote, they haven't published a single scientific paper over the past decade. Just check their record. Whereas I publish every week. I publish a scientific paper every week. I'm in the trenches. I'm a real scientist talking about what I'm doing. And these bloggers, YouTubers that attack me, they haven't published a scientific paper. They are protecting science against scientists like myself. Like, where the hell is that from?
Yeah. I mean, I hope you don't stop, and I hope it only makes you hungrier. Every kind of person who says stop, just keep going and go 10 times as fast, because this is what science is about. It's about literally putting your own dent in the universe and finding what no one has found before. And unless you do that, you're not a scientist. You're just, I don't know, you're someone who's trying to repeat history, but not trying to find something new,
Thank you. Yeah, that's exactly what my thought is. And also, I'm willing to have all the bruises from the pushback, because it's just like putting my body on a barbed wire so the next generation can walk over it, have a better future.
Now, maybe we can inspire the daughter of the pilot even more with the last question. Now, what would finding intelligent life, mean for humanity's history or story as a whole? Not even history, but like story as a whole. What is yet to come? How would that future look like if we really, if we dream, maybe even a bit beyond because now it's data. I hear you, and I think it's very important, but maybe you can inspire her even more. If you really if you showcase us how could this future look like, how great it would be.
Yeah, so I think it will inspire humanity if we realize there is a functioning technological device that visited us after 1 billion years in space. It will inspire us to do the same, because, how can we be proud of ourselves if the role model is not Elon Musk, but someone much more accomplished. Okay, so we need to develop the same capability. And that would mean investing, annually $1 trillion worldwide. And my hope it will bring people to cooperate, because we are in the same boat on Earth. We are all in the same boat, and we better work together rather than fight each other. And that's the message. The universe doesn't care about our fights. The Earth would eventually be consumed by the sun. Nothing will be left of it. And the only civilization that would survive in the long term for more than 1 billion years from now, and by the way, 1 billion years is just a fifth of the age of the solar system. So we just have 20% left of the lifespan of the solar system as a habitable place. The Earth would lose its oceans. All liquid water on the surface would go away in about 1 billion years because of the brightening of the sun. So if we don't get the message that we need to work together to leave the Earth, we would perish on this planet. And there must have been a lot of tragedies like that, a lot of species that were destroyed by their star brightening up, by some impact of an asteroid, by all kinds of catastrophes. They were not smart enough to leave their planet because they were occupied with zero-sum games, on the planet, politics of the day, showing off. I'm smart, I'm powerful, like, who could be more powerful than a dinosaur? Like, and then came this giant rock 10 kilometers in size and destroyed all of them, these non-avian dinosaurs. So it's just a lesson to realize that you can feel very powerful relative to your environment, but then something bigger comes along and wipes you out. And that's the lesson from the universe. So the only thing that would allow us to survive long term is working together and building some trips or spacecraft that carry us to interstellar space. That's the future. And the sooner we realize that, the better, because we would not waste resources and time on conflicts, which is what we're doing right now. And work together, invest all the same resources towards space exploration, because that's where most of the real estate is. So it's really my hope that there will be some monument left of humanity. And the only monument left of humanity would not be on this Earth, would not be on the moon, because the moon itself will crash on Earth once the sun engulfs both the Earth and the moon. As a result of friction on the envelope of the sun, the moon will crash back on Earth, and then the Earth will be delivered to the core of the sun and burn up. All of this will not remain in 1 billion years, in several billion. I mean, the sun will engulf the Earth in 7.6 billion years. So it will take a little longer, but eventually nothing would survive. The only way for us to maintain some monument that we existed is by exploring, going to interstellar space. And the sooner we recognize that, the better. Let's work on it. And I find that much more inspiring than going to Mars, frankly.
I hope you can be the domino, the first one who made that happen, honestly. Maybe, I don't know, in 1,000 years, in 2,000 years, from here, 10,000 years, whatever, we can look back and say, wow, there was this guy, on the internet doing crazy stuff, and turns out he was right. And yeah.
By the way, over the past decade, I led what is called the Starshot project, which was to launch a tiny spacecraft to the nearest star system within our lifetime at a fifth of the speed of light. So I already was involved in an attempt to design such a mission, but it might not happen in my lifetime, but my hope is that it will happen in the lifetime of your generation or the generation after that.
I really hope so, because you're going to make our life so much more interesting, if all of this happens. And if I can choose option 1 where none of this happens, option B where all of that happens, or even some of that happens, I know my choice. It's easy.
Thank you.
Thank you so much, Avi. It's been a pleasure.
Thanks for having me.
Thank you.